Hello, 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 and welcome to episode 3 of Live Coding with Gerph. That's clearly the title of what I'm doing, I guess. Hopefully, because I'm still getting used to this, we have some streaming working, and hopefully there's people around to watch it as well, but yeah, we'll see. Right, so let's start with what we are doing. What am I doing? So, yes, I am working on porting a disassembler from some GitHub sources that was written some time ago, and making it into a debugger module. And first session we ported the code and created the simple swis. Second session added star memory I and star dump I. Hopefully this will all be quite exciting and we'll get something done. What did I say I was going to do? I said I was going to add in the star memory disassembler. So hopefully that will be doing the right thing. Let's get started. I'm a little bit out of sorts today, so we'll see how far I actually get with this. As I say, I'm aiming for star memory and star memory A maybe, and probably some of the other bits and pieces that the module provides. So let's get started. We have a look at some code over here. Actually, no, let's start out by looking at what the documentation says, because I've forgotten. If I go back on this, because I've left this exactly where it was before, we should have overused. Oh no, that's something quite different. Go back again. I want the disassembler code. All right then. All right, so debugger _ disassemble is what I was looking for. In fact, yes, this is exactly what I was looking for. So, okay, we've got probably 3 I can do here. There's probably the InitStore, star memory, and star memory A. I suspect that InitStore will be the simplest of these because, well, it just writes the same word to all of memory, and that's pretty simple. And given that, I think what I'll do is I'll try and implement that one first. So very first thing is pyrodev. Let's run a simple command that is help initstore. What does my help say about it? I'm assuming it will actually work this time around because I made a mistake last time and had the wrong thing checked out. This time I've been more careful. Fill the application space with an invalid instruction. I'm not sure that's actually the full thing. I think InitStore actually does a bit more than that. So calls, break clear. Yeah, I'm not doing the breakpoint stuff, all the debugger type operations. I'm going to leave those until quite a bit later. Yeah, so there's a value or there's a register. Okay, well that's not too bad because we can provide that. So first thing to do is to update the module definition to have a star command for it. So let's scroll down to where the star commands are. Here we are, command keyword table. And actually we want something very similar to dump I, in the sense of it's the same sort of command. Right. InitStore. Now it only takes one argument. It can either have a value or a register, it says, which is quite handy actually because I think we've already got a function that does that. InitStore. And delete all of these back to here. This means we've actually got better help in this than in the other commands in Pyromaniac, but That's because I'm lazy and pyromaniac. I only do the absolute minimum of what I need to do. Right, some help here. We've got a couple of people on. Oh, we've got a few people, 4 people apparently on the chat. InitStore, InitStore. That's twice I've written that. This is embarrassing. InitStore initializes the application space with a given value. Yeah, that looks okay. And we'll have a dedicated command for it, function for it. Save that. It only takes 1 argument. Cool. Actually, I think it takes 1 or 0 arguments because I think it defaults to another invalid instruction. Yeah, so it says here in the documentation, it fills the value with E6000010, which is an illegal instruction. Now, cunningly, yeah, if you like, cunningly, in other architectures, that may actually be an invalid instruction as well. Like in ARM64, that's also an invalid instruction because the top nibble of that has 2 bits clear, which I think it's 2 bits clear or 2 bits set. It's some combination of bits that are in it that indicate that it's invalid, and it just happens that those are always set in the always case, which is actually kind of cute. So we're going to use that value because, well, let us use that value, and we'll actually describe that. Come on over here. Ooh, everything's lovely and slow. If not supplied, the value used will be, which is an illegal instruction. I wonder if it's illegal in thumb as well. It'd be interesting to find out, I suppose. Yeah, because we need to now make those have square brackets to mean that it's optional. Right, there's InitStore. Okay, so in the veneer now we just need to implement it. Which, well, that should be easy, shouldn't it? I wonder if I should move the star commands into a separate file, just to be a little bit more obvious about what's what. Could do that, I suppose. It's not vital, so I'm not going to worry on it too much. Come on. InitStore. Right, now I want to get a value that is either a word or a register, and I think we already did that in parse memory parameters. CLI parser, that's what it's in. There's osread unsigned. Yeah, we haven't implemented parse register or fetch register yet. We'll have a look at that later. It's called param, which can either be a register or some hex. Well, that looks pretty reasonable, I think. Okay, so let's do that then. So we just call param. Is param exported? I assume it is. Wasn't. No, it's not. Okay, let's go and add a definition to the header for that. Copy and paste it in here. Maybe param is not a good name if it's going to be exported. Let's change it to parse value or reg. Oh, I think that's quite reasonable. Pass value or reg. That's a better thing. Okay. This is where having a nice rename function would be quite good, because now I've got to go and replace all instances of param bracket with ooh, little spinnies. What's going on? The machine's clearly being busy. It's either that or I've accidentally quit things. Yeah, I've accidentally quit things. Oops. Apparently that was the wrong key to press. Let's fire things up again, shall we? My screen's just filled with stuff. Just give me a moment. It's doing its spinny thing. Quitting your editor when it's got loads and loads and loads of documents in is unwise. It's possible, of course, that having loads and loads of documents may also be a part of that problem. One nice thing about Sublime Text is that when you quit it, it saves the entire state of everything, all the window positions, all of the documents you had open, and all of the content of those documents. So if you've edited them, they remain edited. If they're new documents, they remain there. So they're all saved. So if you do accidentally go and quit the application and lose your editor, you can restart it and everything will come back. However, it also doesn't expect that you have quite so many documents present at the time. I'm still doing spinnies at the minute, so yeah. That was foolish. Okay, well, in the meantime, let me just have a look over here. So yeah, that was InitStore. InitStore is going to do the filling the memory with data, and in order to implement that, we also need to call os change environment to get the memory limit. So here's the memory limit handler, which just happens to be called 0. That's handy. And the memory limit is in R2. No, memory limit is that's not documented very well. Pointer to new handler is in R1. It's not actually the handler, it's actually an address. It's really not very helpful, os change environment, because it would make more sense if it was in R3, since R3 is a pointer to a buffer. Oh, it's actually a number, isn't it? I don't know. They're not very well defined, basically. Anyway, oh, we're still going. We're still waiting for stuff to recover. Right. Yes, kittens. Very quickly. Come on. You're going to pick up? Oh, and move very slowly. Yes. There we go. We have some kittens. Those are Mum and Dad's old kittens. Dad got a really nice photo of them there. He saw there was 4 of them just sitting, staring out into the field. And when he came to take a photo, they saw him and just looked around, and it was like, oh, that's perfect. You don't normally get them being quite that cute, but it was yeah, rather nice. Right, let's see if we can reorganize this to be sane. We're still beach balling. Anyway, yeah, so I was saying about the memory limit. So the memory limit handler tells us what exactly the top limit of the memory that we can actually use in the application space. So we're going to fill from 8,000 all the way up to the memory limit. Well, that's the plan. It's sort of equivalent to the base of screen memory, I suppose, if you're on a BBC. Not that that would mean very much to most people, I suspect. Or possibly the high watermark. No, high watermark is the low address, isn't it? Anyway, sorry. Well, this is thrilling. Fortunately, I will leave a block in the jump points to say, skip this. This was the editor restarting. I mean, the B4 is quite pretty. It does look a little like the lollies. Oh! I think I've just got an editor back. Right. What? Okay. See if you're going to position. Hey, here we go. Right. Except I've now resized the wrong window. This is part of my what do I call it? Disassembler. Let's move that down here, and let's move the actual one I wanted up here. ICT support suggests a reboot. Yeah, I think this machine is just still struggling. I did get a better machine, but it's still struggling with the extra streaming of everything, which is fine. I'm not really going to be knocking it too much. Yeah, it is very laggy. Right, okay, I'm back though. So let's try our replacements again. So I want to replace param bracket with pass value or reg bracket. Dum, dum, dum. And that'll give us some values there. Cool. All right, so now we return that and we've got a set of parameters. Oh, is parameters only a local on this? It probably is, isn't it? Yeah, there, it's only a local parameter. So let's move that in here as well so that we can use it. Otherwise it's not going to compile. Okay. Pass value or reg is what we want. Let's copy that into here. Find the place we were doing stuff. All right, so arg underscore string equals pass value or reg of arg string into param. Param, yeah. And that was a param t. No, param. There we go. I typoed something. Yeah, there we go. Typoed string there. Right. So the value we're initializing with is the value that was in param, and we want to initialize all of memory. So we need to find out what that address was. So I don't have a little interface here to read any addresses. All right, we'll just look to read any values. Let's just create a small function here. uint32 read memory limit. And we don't need to pass it anything. We just need to read it. Okay. So read memory limit. Takes no parameters. Oh, I forgot to describe it. Needs limit of memory in the application space. I mean, strictly, I should probably actually read the base of the application space as well, so that we actually know the two bounds. But I'm just going to leave it at this for now. Returns maximum address in application space. kernel loss error, and we call Swix with os change environment to read from handler 0, and the new handler is 0, and we want to return it into, oh, we need to actually get a value for this. So this is a limit. Okay, so there we go. Oops, I went too far. Input registers is 0 and 1. Actually, it should be 0 to 3. You should really provide all the parameters. Maybe it's not necessary, but I'll provide them anyway. And we also want to return into limit register 1. uint 32t limit. So all being well, this session will only be about 3.5 hours. I'm not planning on being much longer than that because I think that people get a bit tired at that point. So if we got an error back from change environment, we'll just set the limit to 8,000, which will do nothing if we actually tried to use it. So there we go. There's the memory limit. There's InitStore. Right. So now we've got uint 32t mem. This is going to be uint let's do it properly. Let's be proper about this. Application space base. There we go. Now if I change it in the future, I can at least just twiddle it there, or I can make it into a function or something. It'll be a bit easier. And we know what the limit is. Uint 32t is going to be start limit. So now we can assign that. Oh, hang on. Pass reg or value. What did that return? A null if it failed? Null if not passed. Okay, so we can report an error there. So if arg string equals null, return. Oh, I haven't defined any errors yet. We'll just do nothing. Fix me. Put an error here. There we go. That should be a syntax error. Limit equals param.value, and we need to cast that to a uint for mem. No, actually, don't need to initialize that one at all. Whilst mem is less than limit, increment, assign mem. Oh no, that's garbage. Sorry, it's this thing here, isn't it? That's the thing I'm assigning. Not. And this is the read memory limit thing. Is it read memory limit? Get memory limit? Or read memory limit. There we go. Turn null. Wow, that's very exciting. I think that's it though. I think that's all I need. So let us build it. Discuss ammo. Make the module. Ah, right, okay. I forgot to include SWIs. This is the other reason why putting them in a separate, the interfaces in a separate file is actually quite useful. Include SWIs. try again. Cast between function pointer and non-function object at 193. Parse value or reg. Parse value or reg. Oh, yeah. That should be arg string. I passed in a completely garbage thing. Arg string, there we go. Build. Implicit cast of non-zero integer to pointer, that's still there. Because read memory limit returns it as a uint 32, but I actually want to use it a uint 32 t star. Okay, we'll just cast it. And then line 200, I missed a semicolon because, of course, I'm still writing Python code. Well, that built. Okay. Paradev common. Right, let's just drop to the command line. So when I drop to the command line here, we'll have the standard set of modules. This is the ones in Pyromaniac. So if I do initStore here, yeah, it says, oh, initialize to E7 FFFFF. Oh, I think that's because that's now defined to be an invalid instruction. Well, I think we'll use that as well. Let us just insert that code here as well. So printf store initialized up to, and we'll use the memory address as well. So it's going to look a little bit different, but I think it'll be okay. What are the two parameters? So this is limit and param.value. Store initialized up to that address with that. So let's build it again. Bum, bum, bum. Start up Pyro. So rmload rm32.debugger initialized, good. InitStore. Oh no, that's wrong, isn't it? If you didn't provide any arguments, yeah. So what I can do here is if argc is 0, no, we probably want to actually define the value because it's not the proper thing. All right, we'll do it that way then. So let's, yeah, okay. Sorry, I'm rambling now. Right, uint 32t value. This is the value we want to populate with. Value equals default init store value. Okay, so if you provide no parameters, you get the default one. Otherwise, we try and parse it, and if we didn't parse it, we get an error back, and then the value should be assigned value equals param.value. So now we can just use value there, and we can use value here because param is no longer valid. Whee. Okay, stop that. Oh, I've also not defined this, have I? Actually, I'm going to use the same. I should put these together, shouldn't I? Define. What was it? OX E7 1 2 3 4 5 6. Okay. Cut those. Let's put them up at the top here. And I need to also change the documentation as well. Oh, let's make that a capital E, shall we? Yeah, that's better. Documentation as well, because this is getting tight in here, isn't it? If not supplied, we'll be using that. There we go. Oh, let's just indent that so it's nice and tidy. There we go. All right. Move that to left and then rebuild it. Let's see whether we build again. Okay, run it. Load the module and do an initStore. Store initialize up to blah with etherFFF. That's quite nice. I'm quite happy with that. Yeah, I'm quite happy with that. So that's initStore now implemented, which is kind of cool. Let's get this committed. Yes, actually, is that right? That's a lot of changes. A lot of files changed in there. Is that right? Oh, yes, I moved everything around, didn't I? That's right. Okay, that's all right. Commit minus A. What's the words I'm looking for? Added an implementation of the start initStore command. Start initStore will initialize application space with a value. By default, an invalid instruction. When we come around to doing 64-bit stuff, we can actually cunningly use the value 0, because 0 is also an invalid instruction. But we could use the that E instruction as well. To do this, the parameter reading function was moved around so that it can be used to read the parameter supply. That'll do. To start initStore. Okay. Good. Push that. And if we have a look over here, we should be able to see that that has been, oh yeah, except I've got the wrong branch. Oh, I'm on master. Yeah, I probably shouldn't be on master. I should probably have created a new branch and then done it there. It's only me, and I've only added one line, so it's not like it's a big deal. Well, one command rather. However, I'm going to do star memory next, and I think that's going to need a bit more. So let's do that as a second thing, as a separate thing, as a branch. Git checkout. So we're going to start writing the code for star memory. So add memory dump command. And the command for that is star memory, which memory, is that actually going to find it? Oh, it is. 4782, 4782, yeah, it's around there. Just go there. Actually, there's a link there to it. Follow the link. There we are. That's star memory I. That's not the one I wanted. Star memory. Ooh, A. Ooh. Star memory A does a bunch of things. Well, this is interesting. I didn't know it did these stuff. I thought you could just populate it with one value and that was it. Okay, well, I guess I'll do that one later. Yeah, let's just do star memory first, and then we'll move on to memory A, because that is probably going to be a bit more fun. Yeah, I hadn't realised that at all. I've only been using RISC OS a little while. I mean, who'd have thought? Yeah, okay. Sorry, getting distracted and not realising what I'm doing. Okay, so amusingly, star memory looks very similar to star memory I. So let's put it beforehand. Come on. Star memory. It does have an extra one for byte access at the beginning, it said. So we've got a byte access form here as well. So I need to make that a little bit different. So this is star memory, bracket B, and then we're not actually doing a disassembly, so T or A isn't necessary. And then the following arguments are exactly the same. Yeah, that looks all right. So dumps memory in a hexadecimal and text eval form. Yeah, that'll do. Right. So that's going to be the command we're going to implement. And it actually has the same syntax. So 1, 2, 3, 4, 5, 6. Is that 6 parameters? Or I don't know. Anyway, same number because it's got the same structure to it. So I think we can just leave it exactly the same. And then when we come to the veneer here, if I can find the memory, star memory, here we go. It's actually exactly the same syntax. So memory, byte width instead of, oh, sorry, that's in brackets. And this is also just star memory here. Okay. Okay, we're not doing a disassemble, we're doing a memory dump. We don't need to pass the architecture, we just want to check whether the first character is a B. So let's just do if arg underscore string equals oh no, if the first character is a B and the next character arg string, oh no, the next character, sorry, next character offset 1. Actually, this would be clearer if I did it this way, wouldn't it? Character offset 0 and the character offset 1, that would make more sense. Is either a control character or a space, then the width is 1 byte. Otherwise, I'll call it data width in fact. Otherwise, oops. Data width is 4 bytes. So that gets rid of that. And then the locations will be exactly the same, right? We can supply a default size as well. So let's do this with star memory default size times data width. This will be number of, ooh. We want 16 bytes to be printed per row. So we want a row width, don't we? It's always going to be 16 bytes. Is there any other reason for it to be less than 16 bytes? Can't think so. In the Python version of this, it actually allows for a lot more flexibility, and you can have different row widths, but I'm not going to bother with that. Again, we've got this fix a put an error here. And actually, we should have put that on the other one as well. Just scroll down and put it on that line as well. And this can be dump memory. Except I don't need to know what that is. I just want a data width. Is that it? I think that's about it, isn't it? And actually, we don't need an error report either. Yeah, that looks all right. So I think I'm going to go and implement this in here. So let's have a new file. No, let's not do it in a new file. Let's do it inside here, because we've got this file accessor code here, which lets us access things at different locations and stuff, which is kind of cute. Disassemble stuff. Well, I was imaginative, wasn't I? Okay, well that's fine. Yes, because disassemble memory is just a, yeah, that makes sense. Yeah, so if we copy that disassemble function and call it dump memory, because it's going to be exactly the same, just not dumping. Dump a memory. Dump, disassemble a memory. Some memory. Dump some memory and print it to the screen. Data width equals width of each block, 1 byte or 4 bytes. That's all it can be right now. I mean, I could actually support 2 bytes as well and have nibbles, not nibbles, shorts in there as well. But for now, I think this is okay. Right, so we're not passing in thumb there. I'm going to pass in data width. And of course, the parameter to it is also going to be data width. We're not actually needing an error code here, so we can actually say nothing on that. I mean, strictly, we probably could return an error there. None, that's not none, it's void. Fine. Oh, I really don't know how to write code sometimes. Brain's not really with it. Maybe 1 o'clock in the afternoon is just too early for me. Got 6 people on the stream now. This is at least better than nothing. I don't know if anybody actually watches this. I mean, I did have a comment last night on the RISC OS fireside chat thing that to remind people to watch it. So, right. Anyway, I now need to implement. Oh, not disassemble memory. I've only done half the job here. Do I have a time of day when I'm most effective at coding, says Alan? Yes, usually about 10 o'clock till 2 AM. When it's nice and quiet and I can just get on with things. Although that doesn't always play out because I'm sometimes just way too distracted. But yeah, usually later at night is better time for me. Perhaps a nice cool glass of apple juice will do the trick. We haven't got glasses, but we've got flasks. Flask. I don't know how laggy this is actually being. So you're seeing I'm seeing responding to things as I see them, but that doesn't mean that they're coming out as quickly. I do want. Oh, I don't know. Ooh, ice. Yeah, that'd be quite nice. The spout on this is actually too small to fit ice cubes in, because I have tried. You have to like trim them down or push them very hard. Right, let's finish the job here and actually do dump stuff. So dump stuff is very much like disassemble stuff. In fact, it's so very like it, let's copy it. In fact, it's so very like it, do I actually want to do something different with it? Whoa. Because this bit here, and this bit here are all doing the codey part. And this part is just doing an extra statement on. Oh, this could be. Okay, let's. So. If instead of this being a disassemble function, it was a generic display a dump of memory that just happens to be able to do other things, I could... Oh no, it doesn't quite do the same thing, does it? Because this one does a row length of only one word. So what are the two forms? We've got adra colon word colon text colon disassembly. That's what you get out of the debugger. And when you do a dump, you get adra colon word colon text colon nothing. Actually, you don't get the colon there, you just get the text to there. Or you get byte, 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 byte. Like that. So either you get that or that. And strictly you get that. That will be a half word. So there's the option of a disassembly, and there's the option of no disassembly, of different lengths. Honestly, this does feel like I should be doing it in one block, one function, rather than writing multiple functions to do this stuff. Oh, I also... Okay, I could, but I suspect it's going to be harder. So I'm not going to. Yeah, all right, I'm going to do it slightly differently. Rather than just, in fact, since I've written this, let me leave these as comments here. We write out our disassembly as that. There we go. So, copy, paste. Okay, so this is a new function, which is going to be called dump stuff, which will be very similar. dump some data. Data width 104. And let's copy this. That'll do. Okay. And instead of a thumb, everything's jumped around. Yeah, this is stupidly laggy. Be nice to know what's going on with it. It probably is due to it trying to grab lots of screens all at once. Int data width. If start is less than address, then that. If end is less than address, then exit. I'm not sure what that's checking for, because it can't be less than that. No big deal. Let's optimize it out. And if start is not address, address equals start. Was that a swapping thing? Because address will always end up. Okay, I'm not going to worry about that at this second. I'm sure that made sense at the time, but I'm going to not worry. Right. So we want to read a row at a time. We want to read a row, we need 16 bytes. Data, 16 bytes. In fact, strictly, yes, it should be a uint 8t. And the size we're going to read is row size. Let's actually call it row size. Right. So we print out the address, then we want to print out multiple words. So we need to keep a counter of which word we're on. Actually, we want to keep that counter of which offset we're on, don't we, really? So for offset equals 0, no, you don't do it like that in C generally. That's more like it. Offset is less than row size. Offset plus equals the data width. So we step along in data widths all the way along it. And then we want to print it out in different forms. Since I've got thumb here, this actually means that I've got a data width of 2 already supported as well. If data width is 2, then that would work as well. Although we don't actually put the colon on the end, we just put a space on the end. Actually, yeah, so it's going to be... So our data is in data. This is going to be a little bit long-winded, not necessary to write it like this, but item data equals uint 16 data bracket offset. Doesn't need to be an L there. And then we do similar for this one, which is going to be for 4. This should be a switch, shouldn't it? Data width. Case 2. And traces out. A little bit indenty, but it's fine. Break. Case 1. I think bytes should also be the default. If you supply something that's garbage, you also get it in bytes as well. And it's the same style of thing here. Except this is a uint8. And because it's all, the data is already actually in the right format, that becomes essentially a no-op there. But it will still be clearer nonetheless. But that's what we're doing. They all look the same. Case 4. Yeah, uint16. I mean, I could actually potentially use a do a uint64 as well, but that will be a bit more awkward to do on this compiler. Oh yes, and that's a 8. There we go. All right, so that'll print out all the words going along there, and then we write a textual form of the word, which is actually all in the sense of row width. Row size? Row size. We can't just do this. We can't just extract it from a word. We have to just, but it's just data bracket I. There we go. That's all it is. And actually, because I've assigned offset here as the variable, I don't need to do this. So I can make this a little simpler as well. Use offset. Oh, and I forgot to put the colon between them, so let's put a colon up here. There we go. Colon space between the words and the values. Address plus equals int size. No, that's row size. And then check if escape was pressed. Looks good to me. All right, there's going to be a few problems with this, I'm sure, but disassembles. Like the fact that I've not actually finished changing the function name and all that stuff. Void dump stuff. Right, so now we've got a function called dump memory here, which we can put into our memory I header, like that. Got a semicolon on the end of it, and strictly 4. It's now able to take 4 bytes as well. So that's got to go there, like that. All right. Now, I could wire this directly into the module, but if I wire it directly into the module, I'm going to see that it's if it crashes, it'll be hard to debug. So I'm going to put it into my test code. So you remember we had a DisFile tool up here. This was able to disassemble things. That's all fine and good. And yeah, that seems to do the parsing in exactly the same sort of way. There's two things I could do here. One is I could create a new thing called dump file, which is a copy of this, but instead of calling thing at the end, it goes and does a call to the dump memory instead of the disassemble memory. Or I could just modify this code to allow it and do one or the other, which might be a lot easier since they take the same amount of parameters. So what I could do here is, so we've got so this is actually the correct syntax we have at the moment. We could instead have dump there, like that. Yeah. So if we do that, so if it's a thumb, we do this. If the next first parameter is dump, oops, come on. We'll do dumping instead. Otherwise, oops, bother. Come on. Ooh, 7. Miss me star. So there's thumb and there's dump. We're not dumping by default, but we can if we specify a command line argument. And then this is all exactly the same, unless we're doing the architecture thing here. So if dump, we probably want to do the byte-wise thing here, don't we? So let's specify data size, data width, I think I called it, didn't I? By default is 4. This is essentially the same as setting up the inst width there. Yeah, in fact, actually, do I even use inst width? I don't use inst width. Nope, not used. Get rid of that entirely. It's just data width we need to care on them. Where do we initialize thumb? Oh, it's up there. In fact, actually, we never passed the this architecture thing isn't actually being used. So we should be having a T or A here. This is confusing. Right, let's twiddle how this looks, because there's actually two major syntaxes. Let's actually print out two separate syntaxes rather than try and mix them together and get things very confused. So there's the possibly thumb syntax, which has the T or A in there. And in fact, should I even have a minus thumb on that? Not sure. And then there's the dump form, which can have a B in there for a data width of single byte. So strictly, maybe I should just skip having a thumb up, minus thumb there, and use exactly the same syntax, because that's what I'm parsing. I'm just never using it. Yeah. So let's drop thumb out of this entirely. So we do need to know whether it's thumb or not, but we'll infer that. We'll get that information from the parsed architecture command here, which we can do. How do we do it in the veneer? Because clearly it works in the veneer. Oh, like that. Okay, and that entire thing there is how we do it. Thumb equals that. And that's only if we're disassembling. Arg string is passed. Yep, so this one, if where's memory gone? Yeah. It's arguable that this should be in a parse data width or something function. I'm going to just leave it like this for now, just lazy, whatever. Okay. If dump, if dump else, we're doing disassembling. Oh, of course I haven't actually implemented dump file, have I? And we do want to get back an error from that because dump file name, well, not thumb, so data width, start, end. And actually both of them have exactly the same thing, so that doesn't need to be in there, it can be down here. Okay. That looks all right, but I didn't actually get round to implementing dump file, did I? So here's disassemble file. You know what? All of this is all common things, isn't it? This is all common code. So write a function for it. Disassemble error t setup create file accessor. And we pass in file accessor t the pointer to the accessor, which we're going to call file, and we pass in a start address and an end address because we need to tweak them down here for start and end. So we're going to go and just tweak those. So that's going to be uint 32 and 20 start. P for pointer on the end of those. Sorry if I'm mumbling. I'll try and speak a bit louder. I'm just realizing I'm being quite mumbly. So this looks exactly the same. Oh, hang on, we also return an address, don't we? You know, it feels like there's a bunch of parameters in this that are common. Because I would also be doing this with the other one as well. Comma uint 32_t start address base address. I'll just call it base p, base pointer. Right. All of this code to here. We move in here. So we have a file star f, the file we're going to use. We have a, this is now called the base address, so it's actually base p. And if we get an absolute file, we set it to 8000. The accessor we're initializing gets given a file and some data blocks and a base address. Oh, does the base address ever get returned? No, it doesn't. No, it doesn't. So actually I didn't need to do that. Although it is kind of handy to know what base address you were starting from, isn't it? Let's just lose that, it's fine. Uint 32_t address, since we're not actually needing it, because it gets assigned in here. So these are also assigned the same way. This is slightly different, so start end p. So we update the things we were passed in. Whoa, guys. No, didn't press shift long enough. And now I need to put arrows on all of these. Now, last time I did this, I went and missed a bunch of arrows. And nobody could see what I was doing was because I was jumping around all over the place. So I'm going to try and be a little bit more conscientious and not scroll the screen whilst I'm doing it. So there we go. There, all those have been changed. I can now go and write it. So this is create file accessor. Creates a file accessor, kind of obvious, for the given file or returns an error. Well, that really is kind of redundant, I think, but no matter. File points to the accessor to populate, returns error number or 0. Start p points to the start address to dump to access. It's yeah. NP points to the end address to access or null to ignore. Because some of the time you may not actually care, you just want to access the whole file. If end p not equals null. It's possible this could be a separate function to do those things as well, but it doesn't matter for now. So let's do this. We don't need the file in there. We just need equals setup, whatever it was. No, create, isn't it? Create file accessor, file name, start, end. Oh, those should be pointers to each of them so they get updated. And if anything went wrong, return the error. So that's a lot simpler now. And because that's a lot simpler, I can pick that up, put it here, and call it dump file. Dumper file. Just the data width there, isn't it? Oh, hang on, I've got the comments on this already down here. That one there. Maybe I should have made both of them return dump error, a disassemble error. Of course, that's now misnamed because it's not just a disassemble error, but that's fine for now. I've done that function wrong, haven't I? Because that's actually got to pass in the accessor we are using. There should be ampersand file there on both of those. Right. We've now created a dump file function. Let's put that into memory as well. There we go. Semicolon on the end of that. And let's see if we can compile the program. So RISC OS ammo, file, make file, DisFile. Build 32. Yeah, that didn't work. Line 67. Function type and what? Oh, you're right. That should have been uint 32. Oh no, sorry, int data width there. Oh, this one. Sorry, no, I've read the wrong line number there, didn't I? Int data width. Yeah, on the old style parameters did not require you to put things that way around. Variable mem declared but not used. Line 84 in memory I. Oops, no, 84. Sorry. Huh. Well, I'll leave that alone. I don't care about that for now. 204. Inventing inst size. I've refactored things wrongly then, haven't I? Still got an inst size in here. Is not equal to row size. I wonder if I should put these the other way around. Is that better? And particularly whilst I'm compiling, it makes a bigger difference. Let's have a look. Right. I've missed a bunch of semicolons on my printfs. No, before the printfs. These ones here. Yeah, they were copy and pasted. Any thoughts on whether this is a better layout? I might need to make it a bit bigger. I think context is probably going to matter more to people. Let's just shrink this window down a bit. This window down here. There we go, that's probably a bit better. Undeclared name inventing, oh yeah, I've changed it to offset, but I forgot to change the variable name. No side effect in void context, line 258. Yeah, that needs to return. Oh, that was the one I wanted. Yeah, a T1, that's the one. Right, so now they're going to return the same thing. That'll just make it a little bit easier to work with if they've got, even though it can't return anything. And we could validate memory and make it do that. That might be a good idea. 275 file name. Oh, I forgot the file name. Whoops. Const jar star file name. That's a little long now. Let's go and put it on another line. Yeah, there we go. It's a little nicer. Implicit. Let's rebuild it because I think I've fixed some of those. They'll go. Oh dear. Oh dear. Maybe I've broken some as well. 272. Oh yeah, because I missed the comma. Better. We've got fewer things here. So, undeclared name inventing int f at 326. FFF. It's not this one. 326. It's here. Oh yeah. So we need file to f. Yeah. Because now it's in a different place, which also means that I'll have failed to do that on this one here. File, oh, file.f, not 2f, because it's a structure. Implicit return in non-void pointer, 302. Oh yeah, that's return dis no, I don't know what the thing's dis none, there we go. 387. Yeah, that's why I forgot to put the int in there again. And I think DisFile semicolon after command. What line was that? 91. There. Well, yeah, okay. Yeah, I like this layout better. I think this works better for me. Although it does mean that I may be buried on the side. Oh no, that actually looks okay. As long as I don't have any text that ends up down the bottom right corner over my face, I should be okay. Yeah, so now let's give it a whirl. Dev gos. af32.disfile. Right. So the default operation for DisFile is to disassemble a file. So that's still working. I'm quite pleased with that. Yeah, that's still working. If I now say dump rather than... Okay then. That seems to have switched to thumb mode. That wasn't what we wanted. And it's printing out 3 things there, not 2. That's odd. 3 bytes there. Actually, no, 1, 2, 3. What? 1, 2. 1, 2, 3, 4, 5, 7 bytes. And only 2. What? And everyone's ended up with 38 at the beginning. Well, that's kind of fun. Let's have a see what we've actually written in here. So this is part of the memory I code, isn't it? No, it isn't. This is still... Well, okay, the disassembly is definitely not working. Dump stuff is... Yeah, we're definitely calling the disassemble code. So I need to look at the disassemble routine. Whilst it's less than int size, print out these. That's the characters. What the? 383. Hello there. Common command af32.disFile space hello. Let's bundle the whole thing together in one go, so it goes and automatically runs it for me. So this is the disassembly code being invoked. That is what I hoped. Okay. Now if I specify -dump here, that's still the disassembly code, but now it's switched into thumb and printing out rubbish. And partly it's printing out rubbish because we never initialize it. That's better. Okay, it's still doing disassembly when it shouldn't be, but I've actually got the right thing happening there. So this is, if we specify dump, then go into dump mode. If we're in dump mode, then look for a B or a space and switch our data widths around. Okay. If we're in dump mode, then dump the file. Otherwise, go into disassembly mode. Dump mode. Dump equals oh. We're in dump mode. Dump mode is 1. Go to dump file. I think I know what I've done wrong here. I've just been reminded that it's been an hour and a half now. So Bright Programmer has asked why this slow. I'm not sure what they're referring to, whether it's the output being slow. It's because it's an entirely interpreted operating system running under Python it's intended for debug. That's why it outputs very slowly. Right, so I'm going to try and get this finished to the point where it works, and then I will take a break. And I have a feeling I know what it is. Dump memory. There we go. Dump file is calling disassemble, not dump. And it should also have a data width in there, not a data width. Okay, off we go. Nope. 170. Quick activity. Implicit custom. Because that should be file name there. File name, then data width. Did this even work before? I'm not sure it did. And that should be data width there as well. Wrong number of parameters to create file accessor. Oh, you don't pass in the data width, that's why. Dump mode. Could do with some new lines, but it's looking a bit better. All right, let's go put some new lines in. And if that's all we need, then I'll be happy. Yeah, we just need a new line at the end of this. Boom, boom. That isn't right at all. The disassembler is slow for some reason. Yes, it's all being executed inside the RISC OS operating system that's implemented in Python. So it runs very, very slowly. It's just one of those things about you emulate things in a language that is not appropriate for it, and it doesn't work very fast. If you ran it on a real ARM system, it would run much, much faster. And that is also not correct. It's printed out something, but not the right thing. Read into the into data. Word shouldn't be used anymore. Hey, that's better. And if we now say disassemble it using byte mode. Come on, give me something nice. That's not bytes. It is bytes, but it's printing out with over long. That should have been 2 characters, not. There we go. Yes, I would obviously want to add assertions to the functions to check for them. Similarly, there's a whole bunch of other error checking that can be done in here. There's a lot of this that isn't quite the way you would normally do it. I've swapped those wrong around. There's a lot of nasty, just coding it quickly. The repository on GitHub can obviously be commented on by other people. So if anybody wants to offer a pull request to this, very happy to take it and add it in, because that's what all open source is all about. So there we go. We seem to have terminated early though, which is rather weird. Hello world, R0 on return from it was not set correctly, set to the, and then we die, which is odd. I don't know why that is, but it's kind of working. And because it's kind of working and we've been an hour and a half, I'm going to just take out that little bit of debug I left in there and merge it. Yep, the repo is up on GitHub. You'll see in a second. There we go. Do remember this is not intended to show people how to write well, but how to write things okay on RISC OS, because a lot of people don't bother doing so. I've not added in a whole bunch of error checking or any other conditions that we should be doing. And there should be some fix-me's lying around, but there aren't just yet. Oh, except I haven't actually implemented this properly, have I? Because I've only done this in the DisFile, not in the module. Let's go over to the module. Module dump memory. Okay, let's build the module. DisFile module. Didn't define that. We don't need that. Define memory size is actually the default memory size should be probably around 80 or something like that. 40 rows will do. Didn't do that. But anything that you want to show to make it like better, put into a PR, that would be wonderful. Right, so we built that. Load it and try it. Load RM32 debugger. Memory 8000 plus 40. I left some debug in there, didn't I? That's fine. I just need to strip that dis out as well. There we go. Let's try address 0 plus 40 because that'll have something. Ooh, badness. Did not like that. Okay, what went wrong there? Ooh, that's not what I wanted. Oh, what went wrong there was I have alerts on when you try to read 0 page. So I tried reading 0 page and it told me there was a problem. You're reading from 0 page. Yeah. So yes, that does appear to be returning the right values. I could turn that off, but that's actually a completely valid and expected result. Okay. Build that. Right. Git status. Okay, so this was implemented star memory command. Accessor focus functions. The star DisFile tool now be used for dumping as well. Star dump could be created in the same way. It looks like the dump is cut off at the end of the output for some reason. Needs investigating. Right, that's star memory. I'll push that. And for the person who asked about the repository, GitHub Gerph DARM. It's a fork of J. Bremner DARM, which is available here. And you can have a see at that. So, what have we done so far? We've implemented star initStore and star memory, and potentially made star dump possible. There's still a bug in star memory in that it doesn't seem to cut off properly. It cuts off a little bit too early. I think it's just an off by one error on the rows, but I'll have to have a look at it. I'd also like to put a header on the top of the star dump as well, but I will come back to that. Yeah, so that's good enough for now. That's been an hour and 40 minutes, I think. So yeah, take a break and we'll come back in 5 or 10 minutes. Hi, Andrew. I'm sorry you just come in just at the point at which I'm taking a break, but yeah, I'll see you all in a bit. All right, bye. Just realised I've been talking to myself. I was just trying to say that the license was intentionally a BSD license rather than MIT. When I looked for the repositories to use, I only looked for BSD and MIT licenses because you cannot use GPL inside modules, which was my goal. So that was the reason for that. As for the address sanitizer, ASAN is what Bright Programmer wrote. The RISC OS compiler doesn't have an address sanitizer in it at all, so you can't do anything with that. However, you can use Fortify, command line, a library that can be used with it, which you can build in quite easily to check these things. For a lot of this stuff, it doesn't make a lot of sense to run that inside modules anyway, and that's why you test things in the command line using those tools. I mean, you could also run it, since it's open source, it could be run through the open source program with Coverity. And obviously putting it through linters and the like would catch a bunch of other things as well. There's a lot of things that could be done, but as I say, I'm just trying to get it to a point where I actually got something that works, and we'll tidy it up later and add other bits in. As you saw, the error handling was not ideal in there. All right, I am taking a break now. Hello, peoplings. Oh. Have returned from a short break, and I forgot to make myself tea. So we're just on the pineapple juice now, which is fine. Right. So what we have so far is I've forgotten already. We've just done InitStore this morning at the beginning of the session, and we've done most of star memory, but it was looking like it was truncated, and I'm not sure why that was. So I go back in my history here and have a quick look. The RISC OS website, you'd have to speak to them. So this Bright programmers they went to the RISC OS website and wanted to have an explanation of what the bounties were. They'd like to work on one if possible. You'd have to talk to RISC OS Open about that. I don't have any. I don't really get involved with that because I don't want to do things for money. Essentially, there are areas of RISC OS that need enhancements, and which the RISC OS Open group have decided that they're going to get some money there and offer that for people. Yeah, Andrew has given code at riscosopen.org. If you drop them a line, they'll be able to give you some hints on that and how that works. I personally don't know and don't have any dealings with them, I'm afraid. Sorry, being distracted. But it is always good to have people wanting to work on things. Yeah. So there's some problem in the star memory command that I am trying to work with, which was going a bit funny. So hello world here is, come on. Yeah, that's what it does. And if I do hexdump -c of hello world here, not v, -c. So the last line is not being written out, is what it looks like. That probably means that our address has ended up higher than the endpoint, which is a little odd. Yeah. Is this the right function? No, this is just disassembly one. So this is dumper. We start at the address. If address is less than end. I'm not quite sure about that one. Unless end has been itself truncated. Let's just print them out. I mean, it's not going to hurt, is it? Printf start equals %x, end equals %x. And build and run that. End is 78. Ooh. Start is B, end is 78. It's passing the B as being the start position. It's got the end correct though. Alright, so that means that my parser has come out wrong. Possibly in here. Oh yes, we don't step over it. We need to step over the characters if we've done that. So arg, string, ooh, some of those letters were right. Bum. and that. And that probably also means that it's a bug in the actual veneer. This is why it would be better for this to be a parse data width, wouldn't it? Let's do that. So arg string equals parse data width on arg string with a default of data width, whatever we've got in here. And cut this bit out from here, and we'll put it into the CLI parser code. There's the parse architecture code, and this is going to be the parse data width. Const char star arg string and default. Oh, it's got data width for the data width. That'll be good. That's turn. Oh no, that should be. I need two parameters, don't I? I need both the return parameter and the default. Star data width and default data width. There we go. Sorry, just catching up on the chatter in there. Just catching up with people. I am trying to do a sort of summary of where I'm up to at each of the breakpoints, which I'm hoping will keep people up to date. We've got 7 concurrent viewers at the moment. That is not too bad. 6 now. Fine. Not too bad. And then we assign to data width p at the end. Probably didn't need to do it in a local variable, but there we go. And return const. Okay, so this is very much like the architecture parser. Parse the data width string as supplied. String. No. Oops, daisy. G, B, or H. Yes, there we go. I'm going to process H. Let's give it a half word. Maybe I should also include W as well, so it's got a consistent interface. Yeah, that might actually be a good idea. So, if it's a half word or if it's a word. W for 4 bytes, H for 2, for 1. Okay. And we'll copy that into the thingamy. Header file, CLI parser, header file, parse architecture, parse data width. There we go. Yeah, that's good enough. And with that implemented, we can now go back to DisFile, use pass data width there. And I need to ampersand data width, passing in the default data width as data width. I can probably put that straight into here as well in the veneer. I'll scroll past it. InitStore. Is this memory? That's dump I. Memory I. Memory. Here we go. So rather than doing this, I can do that. And we set the data width by default as being 4. Okay. And now strictly the syntax becomes BWRH. BWRH. And that also means that the mod header needs to be updated. B or W or H. So let's compile the DisFile tool. Right, we're now starting from address 0, but we're still getting terminated early, which is odd. So this row should be starting at 70, and 70 is less than 78. Memory. While address is less than end. Oh, because we don't read a full row size, do we? Data red. Yeah, that's why. We don't read a full row size, so we give up. So data underscore red equals that. So we don't just give up if we didn't get it all. Only if data red is 0 do we give up. And then we print out the address and we go through the entire row. But if offset, actually it's offset plus data width is greater than the amount we read, we just want to print out some spaces. Some spaces. And the number of spaces we want to print is, is data width times 2. Sometimes, so Andrew said that finding bugs like that would take him a lot longer. Sometimes it's experience, sometimes it's luck, sometimes it's also, I've implemented this same chunk of code in Pyromaniac not so long ago, so I have a little bit of an advantage in that I've done something similar. Let's have a see if that works. Oh, pigs in space. Right, there we go. It now stopped at the very end here, but it didn't stop printing it here, where it should have done. So let's just fix that, because we've got the same thing to happen here. Here we go. Yeah, this is exactly the same context. In fact, it's almost exactly the same. No, it's not quite, because we don't do this quite the same thing. If offset is greater than I think that's right. Print, just put a space in there, otherwise Andrew just said, live coding is one thing, but live debugging is another. They kind of also go hand in hand sometimes, particularly when you make mistakes. You missed the very exciting list of back traces when I made a mess of things. Looks okay. If I do a hex dump as well to see whether it looks the same. So they put little bars around the outside of it. That's quite interesting. And they separate these out into blocks of 8 as well. That's kind of interesting too. I think those sort of things could actually be quite useful. But I've kept this largely to the same style of what RISC OS uses for its dump commands. I think maybe in the future it might be nice to try and add something similar to this. Ideally, this whole module could be used as part of a version of RISC OS if you just want to replace all of the modules with C versions, which of course we do, because shouldn't have them written in assembler these days. Right, so that's fixed the problem we had with the file terminating early. But one thing that's, I've left some debug in there. Let me just take the debug out. There we go. Let's get that committed. It's probably quite small, isn't it? I flipped around the order, so rather than having the screen one left and right, I've moved it to the bottom. I think it works better. I can actually do the compiling and things. It doesn't mean there's quite as much visible on the screen at a time. I don't know which works better. If people have any particular opinions, let me know, but that's what I'm doing right now anyway. So commit this. What is it? Fix for the star. Actually, I've only tested this on... Let's not do that. I've only tested this with the DisFile tool. So let's try and build the module and actually test that works as well, since that kind of is part of the goal. Memory 8000. That looks okay to me. Of course that looks okay to me because I've just typed star memory I, which is not what I was doing, and I haven't loaded the module that I was testing, so... Right, now we'll try it. We'll not do memory I, we'll do memory. And there we go. Same output. This file minus H. Oh, sorry, AF32. This file minus H. File not found. Now if I disassemble 8000, there we go. I can now see actual disassembly. Why can I see disassembly? I shouldn't see disassembly. Star memory should go to dump memory. Oh, don't tell me I forgot to make dump memory call the right routine. No, dump memory does call dump stuff. What's going on? That's not being formatted very nicely, so that's a bug, but probably in the OS rather than... Well, it might be my debugger, I don't know. More like that CMHG, CMunge, sorry. So, veneer. Command star memory, pass the data width, pass the memory parameters, call dump memory. Okay, so if I do star memory B 8000, that's done star memory I 8000. Sorry, from address B. That's not. Right, stop. Dev common command. Oh yeah, rm load rm32 dots debugger command memory 8000 plus 20. Huh. Well, this is confusing to me. Star memory I called. Am I? Well, that would be why. Computers only do what you tell them to do. That's a little better. And display it in bytes, please. Oh, hang on. B isn't actually bytes. B is user address B. Star memory has been called. Failed. Okay. Right. Take out my silly debug now. Dum-de-dum-de-dum. Right. Yeah, that works, and that's it, isn't it? Yeah, so I'm done with that. I'm happy now. Let's get that committed, since I have actually fixed it now. Fixed the star memory command not displaying the full dump. If the final line was unable to be read, it would not be displayed. Okay. Push that. Okay. Star memories are doing okay. Star memory I doing okay. I could implement star dump as well, because star dump is just a version of memory but is talking to a file, and we just replace the file access with the memory access with file accesses, which we've already got here. But file system commands like star dump are provided by file switch commands on RISC OS select, and I think by file switch on other operating systems. Pyromaniac also provides it in the file system commands. I'm thinking. Right. One of the things I didn't do is the come on brain access to registers. So if we have a look in CLI parser here, I'll just make that full screen so we can have a look at it more easily. We've got architecture, data width, reading unsigned variables, reading hex variables, values rather, and then we've got parsing a register and parsing and fetching a register from the exception block. So these are not currently supported. So if you wanted to use them, they would fail. So what we would normally do, if I just go into the system normally, so GOS. Actually, I'm not sure if I implemented this in Pyro. I think I must have done. But if I do memory, so I do ShowRegs to begin with. So that shows me the registers we've currently got. Everything is set to 0. Fair enough. So if I do memory, oh, this is going to give me a lot of bugs, isn't it? So I should be able to do R0 plus 8 or something like that. And it shows me some of the memory that's there. And you could use LR or PC and use the relative registers there. So that would be useful to have. Let us try and implement that. So we want to do this, we need to get the exception block. Let's pull this up here. We need to read the exception block. And the exception block is read by OS change environment. That'll do. Exception registers handler on page 562. Here we are. This is slightly different on modern systems because it's not actually just 16 words long, it's 32 words long. If we go back over here, maniac slash dot, oh, I'm going to have to look it up, can't remember. Oh, about PRMs, program environment, exception register area. Oh no, not that one. This one here. Exception register area. The format of the exception register area is the same as the callback register buffer, which is 17 words long, same layout, but with the CPSR on the end. Its layout is described in OS Platform Features 64. Which we will look at later, but we can definitely get that here. So let us, there's nothing special in that. Go back here. uint 32t star read yeah, it's a good place to put it. Exception registers block. Don't need any parameters. needs the location of the exception registers handler. None pointer to the registers block. uint32 t star exception registers. There we go. Swix. Change environment. Be nice if I had oh, it'd be nice if I had a header for this. I do have a header for this. I think I have a header for this. Give me a second. RISC OS kitten. Env numbers. Yeah, env numbers. And 13 is called exception dump area. Register 0 through to 3, and output 1 is register 1, I think. Yeah, I think it's register 1. The documentation here implies that it's only in register 1, so I think that's okay. So exception dump area, 0, 0, 0, and ampersand exc regs. If error, or null. If null. Just initialize that with null just in case anything goes wrong. And let's change the function to exception dump area, since that's what it's called. Okay. And exception dump area. So in order to fetch a register, uint 32 t star interesting. If exc regs equals null, so we just don't have anything. We should also do the same there in the parser. So if we can't read it, we can't parse it. -1 if not known. So we've passed in a register number. For simplicity here, this is not correct, but for simplicity we're just going to do return exc regs bracket reg now. And that will get us the register out of block. And for this, I'm going to implement it tackily and then we'll work on it better later. If start args are register I actually don't remember how stratool works. Man stratool. Actually, I was trying to avoid using these, wasn't I? I was using the read unsigned instead. Let's just use that. Which no. Which no equals readints from args into args. Couldn't pass it. Oh, except that's wrong as well, because I want to read it into the second character onwards. Otherwise, return original. Oh, if original is less than 16, is greater than or equals 16. That's invalid as well. Okay. If start args s register third 13. Oh dear gosh, I'm forgetting my register numbers. This is terrible. So there's the stack pointer, link register, 14, and PC. PC 15. Okay. Well, that looks like it kind of does the job. So if I just go and try this now. Oh, hang on. No, I've not included the file I wanted, do I? Hash include, actually this is a semi-system header. RISC OS / env first.h. Make module. $153. Yeah, we'll just cast that to an int. And since we've cast it to an int, original or original is less than 0. And the second one was 186. That should be reg num. No, rather than reg num, and that should have a semicolon in it. Okay. Go 876543. Right, there we go. I've now managed to cause it to have a prefetch abort, which means that the register dump is going to be valid. And interestingly enough, I've also got an R0 that's, so I can do memory R0 plus 20. That's it, plus 4 or whatever it'll. Okay, that didn't work. Oh, is that because I need to do that? Didn't we do it that way? Failed. It'd be nice if I'd given a little bit more information than that. Let's just try it with just the R0. Failed. Okay. You know what? Printf exception dump number dump area equals. Oh, not writing Python. Now it's working? The dump it's given us is because I've got low memory watching turned on. So it'll tell me whenever I try reading an area that is invalid. Oh, is in low memory rather. In fact, I can turn that off just so that we're not config watch regions dot low memory. No, none. Apparently that's right. No, it's not. Low vectors. Sorry. And it's no, not none. Okay. That's still reporting things. It's probably because it's going outside of the region. Hang on. That's dumped quite a bit of memory. And it's continuing. Interesting. Probably because I asked it to do 40 rows. I don't know. I'll just turn both of them off. Config watch regions low memory. So that's dumped rather more than see, if I did 0 plus 4, it would only dump me one row. But when I did R0 plus 4, it decided that it was much larger. I haven't updated argsp. Yeah, so that's why. So what we should be doing is saying that's the return value there, and these ones should all be incrementing doing star args p equals args plus 2. Skip over the SP, skip over the LR, and skip over the PC. Better. Still not right, though. Oh, it is right. Sorry, that is correct. Yeah. Okay, if I use my go trick again, go to somewhere that's invalid. There we go. And then do memory R0 plus 20 or something. It's now dumped me from that address, which happens to be the command line. That's the command line buffer. So that's kind of cool. Right, I just need to remove that reporting of the exception address, which I've lost. Where's the exception dump area? Here. There we go. It's possible that we should make that static so that it's read once, because it's not going to change, probably. But it's good. So that seems to work. Just confirm. Yeah, no debug now. Good. Git status. Add support for using register numbers in the memory CLI. The register numbers exception dump area. These are manually passed. Don't use the CPU registers. Push that, and now we have all of the memory dump commands implemented. So let's check out master and merge it. Add memory command, memory dump command. There we go. That can get merged into master, and we'll push that as well. All right. So now we've got star memory I, star InitStore, star dump I. We don't have ShowRegs. And ShowRegs I implemented in C for my disassembler module a little while back, because I wanted to make sure that my handling of OS platform features 64 was going to work properly. And implementing it in C was way more sensible than trying to implement it in the assembler code, because I'm not writing assembler if I can help it. So what I am going to do is pinch the code from that from where I created it there. So /projects RISC OS modules RISC OS sources programmer debugger. I'm hoping that's the right location. Here we go. This is the debugger I've got. And this is the implementation of ShowRegs. I just realised this text is probably okay. Size-wise. So this is also this implementation describes CPU features to get the information about the table of the layout of the registers. So the table has it reads back table. It's got an architecture identifier in it that says what architecture of registers it's talking about, the size of the instructions, and the length of the register dump block. So on RISC OS it's going to be 17 bytes, and on ARM64 it'll be 34 times 4, I think, and on 6502 it would be like 20 or something, and the entire block then is followed by a set of definitions which contain a register identifier, a value to say what the type of register it is, and then some information about the block. So this says how far from this in this block you need to go to find the name of that register and the offset of the start of the register dump of that register. There's also information for some registers that may not be present in the register dump. So there may exist a register that you just don't see. And that may make sense in some circumstances. And then we've got a flags block that describes what information is. So how big the register is, what type of register it is there, and then the alignment it must have. So the alignment for all of our registers in ARM32, except the PC, is 1 byte. They've got 0 alignment. They're aligned to a byte. But the PC must be aligned to either a 2 or a 4 byte alignment. For ARM, it has to be a 4 byte alignment. So it would have the value of 2. And then there's potentially you could have a 16 byte alignment. Now 16 byte alignment may seem like a big restriction to have on a register, but that actually matters because the stack pointer on ARM64 can be limited to be 16 byte aligned. It's all fun. And they can also describe additional flags to show what type of flags are there. So for example, in the CPSR, the processor state register, there are flags for the mode, flags for the V flag, the Z flag, interrupts disabled, and a bunch of others. I can actually show you what this looks like. Well, a slightly less technical form of that, or maybe more technical form, I don't know. I've forgotten what I'm writing though. Give me a moment, I'll just... Excuse me. Right, I've moved back to over here. Emulator.py. This is the abstracted emulator in Pyromaniac, which has a lot of stuff in it. Oh, it's not the emulator I want, but the registers. Registers.py, sorry. Stupid. Yes. So we actually have a structure here that defines the different things: the register number, the name, the bit width, the exception offset, and whether it's a synthetic register, and its alignment. And these are actually defined in a big table here. So this structure here turns into the definition of OS platform features 64. And so you get a bunch of flags here that define each of the flag types, what bitness you're in, the different encoding modes, and a bunch of flags. All of which is potentially a little arcane if you're not having to deal with these sorts of things. But, as I say, I've implemented all that, and it's documented, so that's all good. So, what was I doing? So I was just showing you that so that you can see the basic structure of what the data structure looks like. And this is a parser for it. So it will go around and look at the flag fields and try to determine what flags should be displayed. It's all a bit wordy, and I wrote it a while back because I wanted to ensure that I was using things properly. And this is an implementation of ShowRegs, which takes the register dump, information about the last abort info, which comes from OS read sysinfo 7, I think. Not sure, something like that. And then the exception dump region. Now, exception dump region, as opposed to the exception dump registers, is something that somebody asked for on the RISC OS Open forums about 3-4 weeks ago, which describes RISC OS Open forums. I don't remember where they asked for it. I think it was a wish list item. Add disassembly to exception dump. So yeah, Andrew Timmermans asked whether it is possible to have information dumped on the end of it. And I said, well, it's not actually necessary because, well, we get this information on Pyro anyway. And you get a whole bunch of extra information if you've got some debugging turned on in Pyromaniac. But you could also do it separately. So after wittering about that, I then went and implemented this with a description here. And now we produce an actual captured copy from the exception dump. So we can actually get the actual problem that happened. Okay, that's a lot of words. A lot of words for these things, but yeah, that's what we're going to be doing. And largely, we're going to be doing this by taking this code and dumping it straight into the code we've got in here, because why not? That's what it's there for. That's why I wrote it like this. So, I guess the easiest thing actually is just to copy this entire file, ShowRegs, into the code here. So let's just create a ShowRegs file here. Select all, paste, and we need a header file for exception architecture registers. Copy that as well. This is just the definitions that were in that Pyromaniac documentation. So if I pick all that up, yep, CPU ARCH REGS. I've created it in the wrong. Yeah, save that. I think that's saved it in the right place, even though it didn't put it in the right place. Refresh folders. CPU arc reg. There we are. Yeah, I think I was just a bit confused as to what I was doing there. Exception dump region is just a copy of that. New file. exc.dump region. Paste. That's gone there as well. Right. Now the module needs to have o.showregs in it as well. Don't need this debugger file anymore. And this one can be resized. Please, can you resize? Or not? Okay. Oh, yeah, hold it for longer, and then drag. Yeah, because everything's running a bit slow. Alright, so there's ShowRegs. Let's compile that. Compile the module. This is almost certainly going to fail. And let's not have any of those on. Let's just get us to there. You are really not happy. cutils wouldn't open. Okay, what is cutils? Let's pull back this file here. cutils is... Oh yeah, so there's some extra functions in here. Okay, let's just pinch those as well. So get exception area and get exception dump region are equivalents of my... Actually, that seems like a good idea, doesn't it? So rather, in the veneer here, I've just dumped some files in here, so that's some functions in here. So we've got read memory limit, and we've got, what's the other one that I put in here? Oh, no, it was in the parser, wasn't it? So these, reading memory limit and things like getting the dump region, they're all introspection functions. So let us create an introspection file. Introspection. I'm assuming that I'm using the word introspection, right? Introspection being looking into yourself. So that's what how I'm using it here. And we can then pinch bits of code. So read memory limit. You are an introspection function. You can go in there. I've got a typo in here, but that's fine. And the stuff from the CLI parser that did the read exception dump area, that's also introspection. And we're going to have to pinch some bits here from the... here we go. Describe CPU registers, we're going to want that. And we're going to want get the exception area is that read exception dump area function. Goes there. But the exception dump region here is that one. And last abort info. Yeah, so it's read sysinfo. No, last abort. So yeah, I've given it a constant or whatever. Okay. Okay. Introspect. Reading information about the system that we are on. And the date today is the 7th of July. I normally write it the other way around. Before 07. 07. Cute. Include. We want stud int.h. We want swise. We want... I'm going to make the function name exactly the same. So get exception dump. Exception area was actually the thing that it was called here. So I'm going to change it to that. And then the code is exactly the same. What's it called? The comparing the two will be exactly the same. CPU arc registers. And we also include ourselves as well, include a header for introspection. And that will tell us whether we've got any that are inconsistent. Doop, doop, doop. I think that's everything. So now let's create the header. Pick up introspection, dump introspection here, and if get rid of the code. Semicolon. Get rid of the code. And I think we also need to include exe dump region unless CPU arc registers already includes it. It doesn't, so I just need to include that. Include, because I think, yeah, we'll use that exe dump region. Okay. Right. Let's move the debugger code down here for a moment, and we'll go back and recompile it again. And it will fail badly again, I'm sure, because I haven't actually changed anything. So CUtils hasn't been updated. Yeah, fair enough. ShowRegs. Oh, so all of the code here all of the code that I wrote inside Debugger. Pull Debugger back again. In ShowRegs here uses write and write-c, and I think it also has a new line, yeah, write-ln as well, functions, which when run as a command line tool, they just turn into printfs. But in the assembler, we have a CUtils that is implementing those slightly differently, that has actual implementations of these that I was sure I had a write function in there. Is it in here? Oh yes, it turns them into actual inline swis by using the __swy trick here, which allows it to embed the swis directly into the code. You shouldn't really do that unless you know what you're doing, and I believe I do, so I did. Oh, it also looks like I've got some hex and write-ln functions here. I could just pinch the implementation. I mean, it's not like it's particularly... In fact, I could probably have just copied this entire file. That might have been a whole lot easier. Ooh, very fruity hex writing. Instead of actually calling anything, we just go and extract the data straight from a static string to find the hex values. And why not? Copy those. What will I put them into? IO. Why not? Oh, I don't want to call it .c, do I? Silly. Rename. I'm sure other people will be maybe looking at this and going, you're making this way more difficult than you need to. That may be true. IO. To avoid using C-like. So, for anybody who wasn't watching the first session, I think it was. Oh, this is not the right thing. Just give me a moment. I pressed the wrong button. That's the one I wanted. For anyone who was watching the first session, I went out of my way in some places to try and avoid using scanf and stuff like that. And the reason for that was that I wanted to have it able to be embedded as compiled C code, but not use the shared C library. Because if you can write the code to not use the shared C library, then you can just run it without that there. And Debugger is one of the early system modules, so you really don't want it to be reliant on something quite as heavy as the C library. Now, that way of thinking is only really relevant if you're thinking about a very small system and you're thinking about everything being written in assembler. Every other system is written in a high-level language these days. If it's not written in C or C++, it's going to be written in Rust or something like that. And so you think nothing of having a C library moments after you've brought the basic hardware up and identified memory. Your operating system assumes that there's going to be a C library there. So yeah, maybe this isn't the right thing to be way to be thinking about it. But for now, that was the way I was looking at it. I think that certainly if you're going to write anything in the future that is intended to be used on other systems, like ARM64, you're going to want to just start out with C as a first class citizen of the system. You just can't work any other way realistically. You just hurt yourself. And you really don't want to be hurting yourself because, well, life is too short, I think is the phrase. And I probably want, is that it? Yeah, that'll do. This is not very efficient for this chunk of code, but you just replace the whole lot and it will work. So that's those. I now need a header file to contain them as well. Let's just create a header file for that. And again, we just cut out all of the code from that. So realistically, I don't know whether anybody is actually working towards 64-bit with ARC64 other than myself. Certainly I've not actually seen anybody who's put any real effort into that. Although I believe Paolo had done a little bit towards implementation towards HVC, hypervisor controls in one of the things he was trying to work on. I didn't know enough about it at the time, so I didn't really want to get too involved in that, if nadef. But if anybody is considering those sorts of things, you need to be trying to think about how you're going to make it work in the future, and what you can, what limitations you can get rid of, and what things are actually important. Right, this is almost certainly still going to be failing because, well, I haven't fixed very much. Yeah, I haven't even changed the blooming header file, which is the thing I was trying to do in the first place. Not very much use, am I? Back to the top of the file. So this needs to include io.h. We need to include probably string stdlib. I don't know. Let's see what actually else fails. I need to include introspection. And what are the functions? We've got strlen in there, so that's string.h. Yeah, I think I was quite limited in what I wrote on there. And it's got a test program in there, so we can even mess around with that. So, we should include string, string. Go. That's not failed as quickly this time. It's also taking a little while to load. Did I? Yeah, that won't help. I've accidentally included myself. If def introspection I need studint. I don't need swise. I don't need that. I do need that. I don't need that. And that should be okay. Right, let's try that one again. Try not to do it recursively this time. That's better. We got things breaking. Oh, Debugger disassemble. I forgot that was also in there. We can pinch that code as well. I mean, is it really worth pinching it, or should I just, because Debugger disassemble is that call there. Let's just stick it on the end here. Oh no. How does it work? What do we actually use it for? Disassembly equals word base address. That's almost exactly the same. Const char star what was it doing? Word base address. What's word? Is that a uint 32t word uint base? And the actual implementation is that. It's just Agile, isn't it? Rodis. Let's just put it in there. I'm not sure. I'm really just wedging this in now, I think. Which may not be the best of ways of doing it. I could actually have just made it do exactly the same thing there, couldn't I? Change the function very slightly. Doesn't matter. This is just fine. This is fine. ShowRegs needs to include Rodis. I'm trying to leave as much of this actual code exactly the same so that it just works. And I can drop them from one to the other. Function prototype, formal, last abort info type. Did I not define that? Introspection. Let's go back to here. Pick that up and put it in the introspection header. This was going to be really easy because I've already got the code there. Oh, it suddenly started getting somewhere. CLI parser. Read exception. Ah, that's because I renamed the function. I renamed the function. What did I rename it to? Get exception area. Oh, and that's now included from introspection.h. Ah, I missed one. Line number 179. Have I bored anybody to death yet? Have I confused anybody with all the more complex bits that I've added in? Probably. Read memory limits, get exception area, describe. They're all in introspection. So did I add that to the makefile? Or you did not. Introspection. Well, at least one person said not me being confused at things. So that's good. Hopefully, because the code's also there as well, that will make it easier for people to come along and go, oh yeah, I didn't understand it, but now I've had a chance to have a look at it. We can understand what's going on. Maybe. Read sysinfo last abort. So that'll be in this file here, RISC OS read sysinfo.h. Where is that failing from? Introspection.c. Include that here. In fact, I should put it. So I try to keep the headers organized together. So there's system headers, things that you just generally expect to be there, and they should be all the ones that have got the braces around them. Then there's the semi-system headers, the ones that have come out of the OS build and things, and then there's the local headers. And you might have additional libraries you might put in between those two. So they're getting more and more specific to you. Whoops, that was not the button to press. I think that was Control up? No, that must have been Command up or something. I don't know. Inventing exception dump area. Didn't I have that? Didn't I define that one already? Oh, because that's in env numbers. And get default CPU registers. Ooh. Default CPU registers is this table. So this table is the table that I've actually just extracted from RISC OS Pyromaniac, and it contains all the standard headers and all the flags and everything. It might be better off defined separately, but it's fine. I'm just going to copy the content of that and put it in a assembler file here. I've avoided having assembler all the way through this, and now I've got an assembler file. Typical, isn't it? What have I done? What have I done? I've accidentally pasted it into there. I didn't mean to do that. Okay, let's just create an assembler file. So RISC OS, new folder, S. I mean, I could turn it into a C structure as well, but it's not really necessary. New file. Default CPU regs. Oh, that. All copy, paste. Thank you. And we have a function to get default CPU registers. Yep. I can declare that in the header. In fact, I'll just pinch the header declaration from CUtils. And get default CPU registers. There we go. And we can dump that in here. So if we're being really clever, you see that the introspection would be going to a library along with all the declarations of what the different types were and everything, and then you would just include that library in both this debugger and in the assembler debugger, and it would work if we were clever. Oh yeah, and of course you then just link against the right things, which of course you have to do. O.default CPU regs. There we are. Build it. Oh, thank you. You took a surprisingly long time there. Okay. ShowRegs. I haven't actually hooked it in yet. Fine. Spin to the end. ShowRegs. Min args 0, max args 0, add syntax. Star ShowRegs. See you, Alan. How long have I been? Yeah, this is coming up to my 3.5 hours. I will try and keep it shorter anyway. Have a good afternoon. It'll be on stream anyway, you'll see it. Plays registers on the last section. I'm going to call it command ShowRegs there. Build it, that'll fail. Ooh, no, what happened there? Handlers. To read the error message. There we go. And then ShowRegs doesn't have a header. Just create a header file for that. And I'm using introspection.h as well because I'm using some of those types. Looks okay. Now in Veneer, yes, I'm humming to myself. Very out of tune and all that. ShowRegs. Okay. And the implementation of ShowRegs is going to be to call the other command ShowRegs that has lowercase in it and passing in the right parameters. I think if I look down here, yeah, here we go. This code here is pretty much exactly what I want, without the like direct manipulation that screws with it. I think that looks okay. Non-formal, what the heck? That probably means I forgot something on the header for ShowRegs. Yeah, there we go. Forgot the semicolon. Past arc delay not used, fair enough. Railtype pointer mismatches that. Okay. Implicit return, that's a bad one though. What does that mean? It probably means I've forgotten something somewhere in 245. Oh yes, you need to return null, otherwise we'll be returning an error pointer that's garbage. Is it 230? Yeah. There we go. I think that gets rid of one more warning as well. There we go, 2 warnings gone. ShowRegs. No dump present. Well, you're quite right, there isn't. Basic, p% equals and 9,000 to mov LDR PC, no, what? Mov R0 number and number and 8, 1, 2, 3, 4, 5, 6. That memory won't exist, I don't think. And then LDR R0, comma, bracket R0. Call 9,000. Bought on data transfer. Good. Star ShowRegs. Ooh. And there we go. It now shows us the registers, the last abort location, the fault location there coming from the, what's it called? The OS read sysinfo 7, I think it is. I can't remember what number it is. All these registers here have been displayed using the decoded version of the architecture register flags, CPU register flags. Even the CPSR here is being decoded along those terms. So that's why it looks like that. And then this was captured into a register dump area and shows us where we had the fault. PC is slightly wrong because of how the tracing works inside Pyromaniac. But that is working. And that's pretty cool. We now have ShowRegs. So if I do star help debugger, we now have dumpi, initstore, memory, memory I, and ShowRegs. We're missing the memory A, which Andrew wanted, and we're missing all of the other debug functions. But I think that's pretty functional. And because I think it's pretty functional, I'm going to go and give it a new version number. I think it deserves it. So let us first go and commit all the code that we've missed. So C, git add C, H, and S. Because there's a lot of other things that we've added now. Lots of new files there. Commit minus A. Added implementation of star ShowRegs from existing debugger module. The debugger module had been updated by me some time ago. To include use of the what are they called? CPU register. I forgot what I called the bloody thing. That's really good. I've forgotten what I called it. We describe CPU registers. Interface. It also includes the exception dump region, which was recently added. This code was lifted wholesale and dropped into the module here and just works. Yeah, that'll do. Right, so vmanage inc version 0.02. Push. And we're done. I'm going to call it a day there. I'm reasonably happy with that. I mean, whether it'll actually work on other real systems, I'm not sure, because there's still some functionality from Debugger that isn't present, from the standard Debugger, classic Debugger, that isn't present. But I think it's gone quite well today. We've implemented InitStore, star memory, star dump could also be implemented off that, but we didn't. And star ShowRegs. Oh, and added in the register relative operations to the memory functions as well. All of which is pretty good. With that, I'm going to call it a day. That's just over 3.5 hours, so didn't do too badly. I hope you've enjoyed watching this. I probably will be doing another one next Sunday. We'll see. I think I'm going to be able to do one next Sunday, but we'll see anyway. Yeah, thank you very much for watching. Source code is all available on the GitHub site, so you can see the latest and greatest things that have just been committed. Yeah, see you all later. Bye.